Hello, my name is Camila Gomez, and with my partner Valeria Riaño, we are going to explain the types of diodes. Okay, in this opportunity, I explain you schottky diodes. The schottky diodes, also known as fast recovery or hot carrier diodes, have a silicon compositions and are characterized by a very small voltage drop and very fast response. The junctions of the type of diode is metal N, that is, it goes from a metal to a semiconductor that begin polarized in the direct directions. Its voltage drop is between 2.0 to 0.5 volts. Okay, the physical compositions. Schottky diodes are constructed with a metal electrode attached to N-type semiconductor and construct of a metal compound one side of the junctions and put silicon on the other. The schottky diode has no depletions layer and is classified as a devices unipolar, unlike typical p-n junctions diodes, which are bipolar devices. The most common contact metal used for the construction of schottky diode is lead, which is a high conductive compound of silicon or metal. The silicium metal silicon contact has a reasonably low ohmic resistance value, allowing more current to flow and producing less forward voltage drop of around 0.4 voltage when conducting. By schottky diodes. When the metal is attached to an N-type semiconductor, the conduction band electrons, free electrons, of the N-type semiconductor will be displaced from the semiconductor type N to the metal to establish a state of equilibrium. We know that when a neutral atom loses an electron, it becomes into a positive ion, and when a neutral atom gains an extra electron becomes a negative ion. The conduction's bad electrons or free electrons that cross two junctions will provide additional electrons to the metal atoms. As a result, two metal bonding atoms gains extra electrons, and the inside bonding atoms lose electrons. And atoms that lose electrons and the inside junctions will become positive ions, while atoms that gain additional electrons and the metal junctions will become negative ions. Schottky diode forward bias. If the positive terminal of the battery is connected to metal and the negative terminal of the battery is connected to the N-type semiconductor, the schottky diode is said to be forward biased. When a voltage of forward bias to the schottky diode, a larger number of free electrons in the semiconductor of type N and in the metal. However, two free electrons in the N-type semiconductor and metal cannot cross two junctions unless the applied voltage is greater than 0.2 volts. Reverse bias schottky diode. If the negative terminal of the battery is connected to metal and the positive terminal of the battery is connected to the N-type semiconductor, the schottky diode is said to be reverse biased. When a reverse bias voltage is applied to the schottky diode, the width of the blade resistance increases. As a result, electrical current stops flowing. However, a small lake current flows through the electron's terminal exerted in the metal. If the bias voltage is continuously increased reversely, the electrical current gradually increases due to the uniqueness of the barrier. Curve. As we can see, the general shape of the characteristic of the schottky die is very similar to that of standard p-n junction diode, except that the corner to which the diode schottky starts to drive is much lower, about 0.4 volts. Because of this lower value, the forward current of a silicon schottky diode can be many times larger than that of a typical p-n junction diode, depending on the medical electric used. It is perfect for high-speed circuit applications that require fast switchings and low voltage drop. Just like you can see on computers, the limitations of the schottky diodes is that it has low reverse breakdown voltage and a high reverse like current. These diodes are used to reduce the response times on digital electronic circuits such as watches, among others. They are ideal for working with digital logic signals such as high frequency and have a lower voltage drop than conventional diodes.
The photodiode is a built by a p-n junction. It is a device sensitive to visible light and even infrared. In short, it turns out to be a diode with sensitive to light. Most come equipped with a lens that concentrates the amount of light that falls on it. Therefore, its reaction to lighting is more evident. By circulating the current in reverse, it causes an increment in current depending on the intensity of light it deflects. The photodiode responds to change from dark to light and vice versa with much faster speed, and can be used in circuits with a shorter response time. Most photodiodes are equipped with a lens that concentrates the amount of light that falls on it, so that the reaction to light is more evident. If the photodiode is connected so that a current flows through it in the direction of the row of the component, the light that falls on it will have no effects on it and it will behave like a common semiconductor diode. In addition, there are some applications of photodiodes which are fast data transmission, optical measuring devices, and light curtains. Photodiodes are important devices in a variety of applications as they are capable of detecting the presence of light currently and sensitively. Here are some of the reasons why photodiodes are important. Detect the presence of light, convert light into electrical signals, high sensitive, small size, and reasonable cost. The casing of a photodiode allows light to reach the sensitive part of the device. The package may include optical lenses or filters. The material used in the composition of the photodiode is a critical factor in defining its properties. They are usually composed of silicon sensitive to visible light, germanium for infrared light, or any other semiconductor material. Avalanche photodiodes have a similar structure, but work with higher reverse voltage. This allows the photogenerate charge currents to be multiplied in the avalanche zones of the diode, resulting in the internal gain, which increases the response of the device. All these features can be found in the manufacturer's manual. There are two types of photodiodes, which are B. It has a semiconductor diode to which an intermediate zone called intrinsic has been introduced so that the efficiency of the photodiode is high. The problem it presents is that the transit time of the photocarriers is longer, increasing the response time. And the APD or avalanche photodiode is a photodiode with internal gain due to the avalanche effect. It has superior sensitivity. As a result, it allows detection of lower power levels. Thank you for your attention. If you want to know more about the diodes explained above, you can consult the links found in this presentation. Bye bye.